Hello and welcome. In the last lesson, we discussed about the embedded system and understood its general architecture. In this lesson, we shall learn about the microcontrollers used in the embedded system. We shall also discuss how it is different from the general purpose microprocessors. Microcontroller is an integrated circuit, essentially a complete computer system on chip which is widely used in embedded systems. It is also referred to as embedded controller or microcontroller unit. It is the hardware platform on which the embedded software runs and commonly used in automobiles, robots, office machines, home appliances, medical systems, mobile devices, etc. Depending on the complexity of the application, a microcontroller ranges from a simple 4-bit processor to a 32-bit or 64-bit processor. Microcontrollers are designed to be used off the shelf because the components required for a system is readily available on the chip. The availability of the components like central processing unit, memory, input-output interfaces, timers and counters, interrupt controller, analog to digital converter, digital to analog converter, serial interface ports, and clock generation circuits make it readily usable. There are several microcontroller families available in the market. For instance, 8051 from the Intel, AVR family of microcontrollers from Atmel, PIC series developed by Microchip, ARM Cortex family developed by Advanced RISC Machine, etc. ARM designs 32-bit and 64-bit RISC-based multi-core microcontrollers. All these microcontrollers are widely used in variety of embedded systems. The general architecture of a microcontroller is as shown in the diagram. A microcontroller consists of all the features required for a computing system and functions as a computer without need for any external digital components. It contains central processing unit, that is CPU, program and data memory, input-output ports, timers and counters, interrupt control, analog to digital converter, digital to analog converter, serial interface ports, clock generation circuit. CPU is the heart of the microcontroller and consists of an arithmetic and logic unit and a control unit. The microcontroller stores the embedded software in the read-only memory available on the chip. It is called program memory and generally made of flash or electronically erasable programmable read-only memory. RAM is the data memory, which is a temporary storage used during the program execution. Program memory is a permanent memory, whereas the data memory is a volatile memory. Input-output ports provide the microcontroller a physical interface to communicate with the external world. Input ports are used to receive the data from sensors and commands through the input devices. The output port is used to control the external devices like motor, display, LEDs, etc. The timers and counters provide timing and counting functionality for the microcontroller. Analog to digital converter converts the analog signal to the digital form, and the digital to analog converter converts the digital signal into analog format. Interrupt control handles the interrupts generated externally or internally. It is a mechanism to inform microcontroller of an important event which needs immediate attention. Clock generation circuit provides the necessary clock signal to the various parts of the microcontroller. Now, what is the difference between a general purpose microprocessor and a microcontroller? A microprocessor is designed and developed for general-purpose computing requirements used in desktop, laptop, and notepad. Whereas a microcontroller is designed and developed keeping in mind its limited but specialized purpose. Microprocessor is a programmable multi-purpose silicon chip consisting of arithmetic logic unit, control unit, instruction decoders, and register array. Microcontroller, on the other hand, is the heart of the embedded system consisting of all the digital components required to make it a complete computer system. Microprocessors don't have RAM, ROM, and other peripherals on the chip. Microcontrollers have stringent power consumption requirements as these are used in standalone battery-operated systems, whereas microprocessors are designed for raw processing power, operates at greater speed than microcontroller, and power from wall power supply. From the instruction set design perspective, the microprocessors employ complex instruction set architecture and microcontroller uses reduced instruction set architecture. Microcontroller is designed based on Harvard architecture and microprocessor is based on Princeton architecture. ARM's Cortex-M, Atmel's AVR, Microchip's Peripheral Interrupt Controller are examples of microcontrollers. Intel's x86 series of processors, Pentium, etc. are examples of general-purpose microprocessors. With this, we come to the end of this lesson. I hope the lesson was useful. In the next lesson, we shall discuss about the processor architecture. Till then, happy learning. Thank you.